Hello, this is Miss Moreland. Welcome to 12.5 Day 1, least common multiple or least common denominator, okay? Your goal today is to be able to find the least common multiple, but the point of finding the least common multiple is so you can ultimately get the least common denominator, because remember when you're adding fractions, you have to get a common denominator, okay? So here's an example of what we're going to be doing, but instead of having numbers like we did with multiplying as well, we're going to have variables like x squared plus 2x and stuff like that. So just remember with adding and subtracting, it's a little bit harder than multiplying and dividing because the denominators have to match. And if the denominators match, you can go across the top and add those numbers, and the denominator will not change. So it's going to be 3/5. If I'm subtracting, same thing. Notice my denominators don't match. So the reason I need to get a least common denominator is so I can add them. So this one I could make 6 if I multiply by 2, but if I do something to the bottom, I have to do it to the top. So I get 4/6, that's equivalent to 2/3. Now if I write out my problem, I have the same denominator. I can go straight across and get 3/6, and just like always, you never want to leave something that's not simplified. That's the same thing as 1/2. So now that you can kind of recall adding and subtracting with fractions, we're going to start adding some variables. So again, adding and subtracting with like denominators is easy. If there's the same denominator, you add across the top, and the denominator will always stay the same. So we're going to do a few examples like that, and then we're going to move into ones that don't have the same denominators. And that's what we're going to finish up tomorrow. So adding and subtracting with like denominators is pretty simple. If your denominators match, you know your answer is automatically going to have that as your denominator. And you add across the top. Now it's common for people to think they can add 2a squared plus a cubed. You can multiply those, but you can't add them because they're not like terms. So you literally just write 2a squared plus a on top, and that would be it. That's all you can simplify on that problem. Okay? Sometimes you can simplify a lot, and sometimes you can't simplify anything. All right, so we're going to do the same thing on this one. My denominator matches. So pause the video and see if you can write out this answer, because this should be pretty quick. All right, so you know your denominator is going to be b squared. And you do actually have like terms on the top. A b and a b can be combined. So 3b minus 5b is negative 2b. And sometimes your answer is done, but in this case, I have to go back to what Ms. Zielinski taught us when we were simplifying, and I have to be able to cancel. So that's going to be b and a b squared cancel, so I'm left with 1b on the bottom. So my final answer is going to be negative 2 over b. Right, we're going to do like 2 more examples of this and then get into the tougher stuff, okay? So adding and subtracting with like denominators, pause the video and see if you can do these two and see if you can get down to the final simplified form. All right, so what makes these tough is you're going to first have to add. You know your denominator is going to be m plus 4. And then you can start adding and see if you have like terms. So m squared doesn't have any like terms, but 2m plus 3m is 5m. And then I have a 4. And a lot of times that's going to be it, but I better check to see if I can factor this, especially that top. So I want to multiply to 4, and I want to add to 5. Well, that's nice. 4 and 1 multiply to 4 and add to 5. So really I can write this as m plus 4 times n plus 1 all over m plus 4. So this top part can be factored. And now you notice, oh, well, it was pretty nifty that it could factor because the m plus 4's cancel. My answer becomes a lot simpler. It's just m plus 1. So always check with these problems, guys, if you can factor and simplify. All right, our last one is the toughest one, and it's the most common one wrong, and it's because of that negative sign there. You really want to think about it as subtracting the 2a and you're subtracting the 4. 2 negatives make it a positive. So I'll write that out a little nicer. It's 5a plus 2 minus 2a minus 4. If I distribute that negative, I get a negative 2a plus 4. So you have to really think about you're subtracting both parts. So 5a minus 2a is 3a. 2 plus 4 is 6. And I always know my denominator is going to stay the same, and it's in this case a squared minus 4. Now a lot of people think I'm done. And that's fair to say because it doesn't look like you can do much, but you can factor actually both the top and the bottom on this one. On top you should be thinking, well, they both have a 3 in common. So that's a plus 2 times 3. And this is a difference of 2 squareds because 4 is 2 and 2. A squared is a and a. It's a 2 and a negative 2 over there, so it's going to be a minus 2. And again, you can kind of guess to get that because you know you're looking for an a plus 2 because that's going to cancel. So those two cancel and your final answer is 3 over a minus 2. So again, always check to see if you can factor and simplify. All right, now we're going to move on to a couple more examples. I don't have very many left, and we might not even do them all. Are these? Oh, we only have 2 examples left, okay? So if we don't have a common denominator, we have to find it, and that's something we call the least common multiple. So these are the steps, and you won't always use all the steps, but first you're going to factor if you have to. If it's already factored, that's great. We love it. Then you're going to have to use every factor of both expressions the greatest number of times it appears, okay? And we'll talk about what that means in a second. And this least common multiple is what gets you the least common denominator. So a lot of times you'll just see me say, find the least common denominator. Well, really, you're just looking at the denominator and finding the least common multiple. Okay, so let's start with an example. This is one of those that I like because it's already factored for me. So I can see this one just has an x plus 2, and that one has an x plus 2. But this one has an x minus 3, and this one's missing the x minus 3. So the least common denominator would have to be, clearly they both have an x plus 2. But if I wanted to get the denominators to match, I'd have to multiply this one by an x minus 3. Whenever I do the bottom, I have to do the top. So you can see that if I were to do that, the denominator would have to be at the very minimum x plus 2 and x minus 3. And we're not going to get into the actual adding of these or subtracting of these yet. We're just going to be trying to find out what would your denominator have to be if you were going to add them. Okay? Whoopsie, I missed one. So here's our next example. And again, I like this one because it's factored. So what I like to do is I like to circle what they have in common. I know that my least common denominator is going to include what they have in common. But then I need to find what's missing from each. So this one has an x plus 7 and this one doesn't. So I would have to multiply it by an x plus 7. And this one has an x plus 2, but this one doesn't. So I'd have to multiply it. And by doing that, I can see that the denominator that I would have to have is this whole thing. So my denominator would be x minus 7, because that's what they have in common. And then one of them has an x plus 7, the other one has an x plus 2. So in order to be able to add those two, I'd have to have the whole thing. Okay? And that's what it means by take all the factors they share, and then take all the factors that they have. So basically, you take all the factors you see and combine them all. That would be your least common denominator. All right, so this one I don't like so much because it's not factored, but I want you to pause the video and factor it. So this factors to x minus 5, x plus 5. And this factors to x times x minus 5. So I have an x minus 5 and an x minus 5 that they share. So I'm done with that. I know that's going to be in my denominator. Now I need to find what's missing. So this one has an x plus 5 and this one doesn't. So what that would mean is later on I'd have to actually multiply it by x plus 5. So that's going to be in my denominator. And then this one has an x, but this one doesn't. So that would mean I'd have to multiply it. So that means that has to be in my denominator. They don't have anything else left. So that would be the whole denominator. All right, our last and final example I want you to do on your own. Pause it, and I'm going to run through it in a second. So this factors to 4 times x plus 2. And this one factors 2, multiply to 12, add to 8, 6 and 2. All right, so I look at what they have in common, x plus 2. I know that it's going to be an x plus 2. And then I look, this one has a 4 and that one doesn't, so I know that they both need a 4. And this one has an x plus 6 and that one doesn't, so I know that in the end I'm going to have to multiply it by it. So my whole least common denominator would be 4, x plus 2, x plus 6. Okay, go ahead and try the on your own, and I will see you tomorrow.